I'm Dr. Cameron Sheeler with UAB's Biotechnology program. Today, we're going to talk about how to make a stock solution, and from a stock solution to use a serial dilution to make a working stock solution. Working stock solution will be used for all of our experiments. Here, we're going to make 1 molar stock solution of BPA. It's dissolved in DMSO. Why are we going to use BPA? Because my research involves environmental toxicants and their effect on gene expression, development, and potential risk. And BPA is just one of the many chemicals that I'm studying. So after we make a 1 molar stock solution of BPA and DMSO, we're going to want to do a 1 to 10 dilution as a serial dilution. We're going to continue this 1 to 10, 1 to 10, but we're going to talk about how do we make our first 1 to 10 dilution, such that we'll take 1 milliliter of our 1 molar BPA stock, add it to 9 milliliters of DMSO with a total volume of 10 milliliters. That's what TV stands for. So if you see any of my videos, you see TV, it means total volume. We're going to dilute it out so that the total volume is 10 mils. How do we do this? Well, I just told you. This will give us a concentration of 1 times 10 to the negative 1 molar. Now, if we move over to our next board, I want to show you how we did that 1 to 10 dilution and how that will equal 1 times 10 to the negative 1 molar. We're going to go back to our good friend, the C1V1 equals C2V2. C1 is the initial concentration. V1 is the initial volume, and that will always equal the final concentration, which is C2, with the final volume. Now, if we plug this in, we are starting with our 1 molar stock of BPA. We're taking 1 milliliter of that, and we're going to add it such that the total volume will be 10 mils. So we have no idea what the concentration is. Actually, I do. But if we rearrange this, solve for X, solve for the concentration, we've got 1 molar times 1 milliliter divided by our 10 milliliters gives us a number. Why don't we cross these out? Milliliter, boom. Milliliter, boom. We are left with the unit of interest, which in our case is molarity. 1 times 1 is 1, divided by 10 gives us 0.1 molar. You might say, Dr. Sheeler, that's not quite 1 times 10 to the negative 1. Yes, it is. How do I know? Because if I take this, move it once over here, that becomes 1 times 10 to the negative 1 molar. Since I moved it this way, that just means the negative number means I have to move it back to the left. Now we have our 1 times 10 to the negative 1 molar, a B, a P, A. Now let's continue that series of serial dilution. We just did our first 1 to 10 dilution. If we take another 1 to 10 dilution, how do we do that? 1 milliliter of our 1 times 10 to the negative 1 molar. Add it to 9 milliliters of DMSO. Again, total volume of 10 milliliters. We will get a 1 times 10 to the negative 2 molar. We're going to continue this serial dilution. We're going to take 1 milliliter of this 1 times 10 to the negative 2 molar, add it to 9 milliliters of DMSO, giving us 1 times 10 to the negative 3 molar. This is a serial dilution. We can continue this as needed to go to 1 to the negative 4, 1 to the negative 5, 1 to the negative 6. Therefore, our working stock, and the way I design my experiments, I'll take 1 microliter of our working stock, put it into 1 mil of cell growth media or whatever conditions I want to put my test compound in. That will give me a final concentration. In other words, I'll take 1 microliter of each of my serial dilutions, each of these working stocks, take 1 microliter, put it into 1 mil, and that will give me our final concentration. So this is how I make a working stock solution for use in my experiments. If you have any questions or suggestions for other videos, please email me at the below address. See you next time.